the fourth roots of the complex number -8 plus 8i radical 3. We're using the nth root theorem, which requires us to have this Cartesian form complex number written in polar form, which means we have to find the modulus, which is the length of this hypotenuse, actually. Since this is a 30, 60, 90 right triangle, how do we know that? Because of the ratios of 8 radical 3 to 8. So this has to be 60. This has to be 30, and the hypotenuse is twice the short length, 30, 60, 90. Anyway, that tells us that we rewrite this complex number as the modulus times the cosine of theta, which is this angle right here, which is 120 degrees, plus I sine theta. And we abbreviate that as 16 cis 120. And the nth root theorem tells us that to get the fourth roots of this complex number in polar form, we have to do this: 16 to the 1/4 times cis 120, and I'll leave off the degree symbol, plus 360k all over 4, where k takes on the values 0, 1, 2, and 3. That is 0 up to 1 less than whatever root it is we're taking. Okay, so we take the fourth root of 16 as 2. Now, what are our possible roots? Well, if we see 4 into 360 is 90, as we take on the values of k of 0, 1, 2, 3, we can just see that we're increasing this 30 degrees by 90 at a time. So we start at 30 because we have 120 divided by 4. And then if we just keep adding 90, we'll get the other ones. 2 cis 210. Finally, 2 cis 300. And if we added 90 again, we'd be back at 390, which is the same as cis 30. So there are the 4 roots of the original complex number, but we're asked to give them in Cartesian form. So we have to say, well, 2 times the cosine of 30 plus I sine 30. And I'm just going to do the first one here. So the cosine of 30 is radical 3 over 2. And the sine of 30 is 1/2. And if we distribute the 2, we get radical 3 plus I. So what we're saying is that this is a fourth root of this complex number. And by the way, on this circle with a radius of 2, these are the 4 fourth roots of that complex number. And they're evenly spaced at 90 degrees. 90, 90, 90, 90. And you can convince yourself that this is fourth root, and you can do it for the others by raising this to the 4th power. Or say, well, I'm going to square it once, and whatever result I get, I'm going to multiply that times itself. So what is radical 3 plus I, the quantity squared? Well, it's 3 plus 2I radical 3, I'm squaring a binomial, plus I squared, but I squared is -1. So it's 2 plus 2I radical 3. And if I square that again, I better get this complex number, otherwise it wasn't a root. So I'll square the first term, double the product of the two terms, 8i radical 3 plus 4i squared times 3. I squared is minus 1, so this is really a minus 12 here. And 4 minus 12 is minus 8 plus 8i radical 3. Okay, and these points here, this is like the radical 3 plus I. This would be negative 1 plus I radical 3. This would be negative radical 3 minus 1 I, and 1 minus I radical 3. Okay, there you go. Hope that